Okay, inverse functions are a topic that you probably talked about in Algebra 2, maybe pre-calc. And in calculus, what we want to discuss is the derivative of an inverse function. We have calculated the derivative of all sorts of things. And what we're going to talk about now is, given a function, can you find the slope or the derivative of the inverse of that function? Just to review a little bit, the function x cubed plus x minus 1 is shown here in red. The line y equals x is also added because remember that inverses are a reflection over the line y equals x. So what I'm going to do is kind of add in the line, or add in the inverse of y. If this function were called f of x, this would be f inverse. An inverse is basically switching x and y. So our red function goes through the point 2,9. That means our inverse is going to go through the point 9,2. Anytime our function is on this black line, our inverse is going to be also. The point 0, -1 is going to become -1, 0. The point -1, -3 is going to become -3, -1. Basically, any point that is, any point on the red line, we can mirror image over the line y equals x and find its counterpart on the other end. So that blue line right there represents the inverse of the function. It's a mirror image over this 45-degree angle y equals x. And what I want you to focus on is this one point right down here. At -1, our original function has a slope of 4. This right down here is a slope of 4. The tangent line there is at 4. And I've shown finding that. I found the derivative and plugged -1 into it to show that the slope of our original red function is 1 at that point. Now I want to look at the counterpart point. If we flip across y equals x to -3, -1, I'm right here. And I want you to see the slope right there. Since an inverse process is just the flipping of x and y, that's going to change the slope to its reciprocal. All right, it's still positive. It's not like perpendicular lines that are opposite reciprocals. It's just the reciprocal. So the slope right here is 1/4, whereas the slope over here was 4. So let's just get a little background. Now let's look at the formula for finding this without you looking at a graph of both of these. Okay, so here's our main formula for this quick video. The derivative of an inverse is 1 over the derivative of the function evaluated at the inverse function. So that looks kind of crazy for right now, but it's an easy process with practicing a few times. So I'm given a function here, f, and I'm asking you for the inverse, the derivative of the inverse evaluated at 2. Now the difference here is I'm not going to find the inverse of f. I don't even know if I could find the inverse of f in this case because solving for x would be complicated. It probably could be done, but we don't need to find the inverse and then substitute in to find it. We just want to use this formula. So let's just plug in the 2. The answer that I'm looking for is 1 divided by f prime of f inverse of 2. All I did was change x to 2, right? I'm evaluating it at 2. So here's really the key. I need to know what f inverse of 2 is. I need to know what happens when I plug 2 into the inverse function, but I need to know that without finding the inverse function. And here's the trick that makes that happen. We need to know in f of x some coordinates that we can flip around, because remember, if in a function x and y flip. So if, for instance, if 4,2 is in a function, then 2,4 is in its inverse. So my goal to be able to find f inverse of 2 is to know f inverse at 2. This is the number that needs to go in those parentheses in my formula. So in order to make that happen, what I want to do is figure out what's the x value in my original function that's going to produce a y equals 2, or f of x equals 2. So I'm going to take my original function that I was given and set it equal to 2. And the result here, this is kind of a complicated equation to solve because it is a cubic, but the answer should be a nice simple number. It's usually a small integer number. It's not going to be some crazy number. If it were, you weren't going to have that question asked to you anyway. So basically solve this equation for x. You could graph it to solve it. You could guess and check a couple little numbers, but let's just cut to the chase. If x is 1, 2 equals 1 cubed plus 2 minus 1. That makes it true, right? So x equals 1 works, and we found that just by a little bit of observation. It should be, like I said, a relatively simple answer to do with a little bit of guess and check. So what I've discovered is that in my original function, 1, 2 is on that graph. 1, 2 is a point on f of x, which means the inverse must go through the point 2, 1, because that's what inverse means, flip-flop x and y. So that whole little side process right there, is used to figure out what is f inverse of 2. F inverse of 2 equals 1 because 1, 2 is on the original graph. All right, and that's the part that once you grasp makes this process a lot easier. It's a little tricky at first, but once you get quick at that, this will become an easy process. All right, so back to the original. F inverse of 2 is 1. So now I'm back to something I can manage. What is 1 over f prime of 1? Well, f prime of x. F prime of x is 3x squared plus 2. So f prime of 1 is 3 plus 2, or 5. And so now my final answer is just 1 over 5. Okay? 5 because that is the slope of my original at 1, and then the reciprocal of that is 1/5. All right, this side process over here is just figuring out what's the point, where is this happening. All right, so let's try one more. All right, so this time we're going to use sine. All right, and remember what we're looking for. We are looking for f inverse prime at 1/2. And f inverse prime of x equals 1 over f prime of f inverse of x. So I'm going to evaluate this at 1/2. So really my biggest goal here is to figure out where is, let me state it this way. The point something 1/2 in the function f, I need to know what's the value of my inverse at 1/2. And the trick to finding that is knowing where is my function equal to 1/2. So where does sine equal 1/2? Well, sine equals 1/2. On our unit circle, sine is 1/2, and that's going to happen when the y value is 1/2, and that's going to happen at pi over 6. So that means that my inverse goes through the point 1/2 pi over 6. And this right here is just a little domain that's going to make sure our inverse is still a function. So don't really concern, that's not a concern as far as answering this question. Okay, so f inverse prime of 1/2 for this function is 1 over f prime of f inverse of 1/2. That's just changing x to 1/2. And I think that one of the struggles here is the prime and the inverse, the -1 exponent. They start to blend together after a while, but again, with practice, this is not a hard process. 1 over f prime of f inverse of 1/2. F inverse of 1/2 is pi over 6. We have 1 over f prime at pi over 6. F prime of pi over 6, let me again step off to the side. The derivative of sine is cosine. The derivative at pi over 6 is cosine of pi over 6, which is square root of 3 over 2. Remember our unit circle. So f prime of pi over 6 is the square root of 3 over 2. And 1 over that is 2 over the square root of 3. And if we need to rationalize it, 2 times the square root of 3 over 3. Okay, so learn that process. It's likely to be one quick question on the AP exam, so it's important, not huge, but important in small doses.